Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 25 video on the chapter of mensuration, where I will solve the remaining problems of exercise 20E. These problems are based on perimeter of a circle. In the previous video, that is part 25, I solved the first 10 problems, that is question number 1 to question number 10. If you have not watched that video, then please watch that to have a good understanding how I am applying the concept of perimeter or circumference of a circle to solve the problems. Also, if you have not watched the previous 23 videos on this chapter of mensuration, then please do watch them also to have a good understanding of the entire chapter of mensuration. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 25 video on the chapter of mensuration, where I will solve question number 11 to question number 21 of exercise 20E, which are based on perimeter of a circle. Okay, so as usual, I have kept the PDF of my quick notes on the perimeter and area of a circle in case I forget any formula. On the right hand side, I have written down all the questions, that is question number 12. I think in the previous video, I have done question number 1 to 1 to 11. So in this video, I will do question number 12 to 21. I have written down also the answer of the questions so that I can match whether my solution is correct or not. Okay, so question number 12 says one circle has a radius of 98 centimeter and a second concentric circle has a radius of 1 meter 26 centimeter. How much longer is the circumference of the second circle than that of the first? Now, what are concentric circles? So let's say it is given that one circle has a radius of 98 centimeter and a second concentric circle has a radius of 1 meter 26 centimeter. Okay, so what are concentric circles? So let's say this is a circle. Now, if I draw a circle inside this circle or outside this circle with a gap in between, so this is a concentric circle. These two are concentric circles. Also, I can draw the circle inside any circle. So these are all concentric circles. The important concept is that all concentric circles have the same center. Their center is common. So these are concentric circles. Okay, so let's remove this circle. Okay, so it is given that one circle has a radius of 98 centimeter and the other concentric circle has a radius of 1 meter 26 centimeter. So definitely the second circle has a bigger radius, so that will be outside the first circle. So let's say the first circle, let the radius be denoted by small r, where small r is given as 98 centimeter, and let the bigger the outer circle, which is the second concentric circle, the radius be denoted by capital R. So capital R is given as 1 meter 26 centimeter, and it is asking how much long. Since the second circle has a bigger radius, definitely it has a larger radius, so it will be a bigger circle. So definitely its circumference of the second circle will be more. So the radius of the second circle is 1 meter 26 centimeter, which is equal to 100 centimeter. 1 meter is 100 centimeter plus 26 centimeter. So which is equal to 126 centimeter. Okay. So now circumference, let's say I am denoting C1 as the circumference of the first circle. We know the formula of circumference is 2 pi r, where r is the radius. So it will be 2 pi small r, because I have denoted small r as the radius of the first circle, that is the smaller circle. And let's say C2 be the circumference of the second circle, so it will be 2 pi capital R. So the question has asked how much longer is the circumference of the second circle. So difference, so we have to basically find C2 minus C1, that is the difference of the circumference of the second circle with that of the with the circumference of the first circle is what has been asked. So C2 minus C1 will be 2 pi capital R minus 2 pi small r. If I take out 2 pi common, this will be 2 pi multiplied by capital R minus small r. Okay, so I have no space. Anyway, so now this is 2 multiplied by, we will take 22 by 7 as the value of pi. So 22 by 7 multiplied by what was capital R? Capital R was 126 and small r was 98. This much centimeter. Okay, this is equal to 44 by 7 multiplied by, how much is 126 minus 98? 8, 16, 10, 2 centimeter, and this will be equal to 176 centimeter. So the circumference of the second circle is 176 centimeter more than the circumference of the first circle. Okay, let's see the next problem. Question number 13. A rhombus has the same perimeter as the circumference of a circle. Okay, if each side of the rhombus measures 33 centimeter, find the radius of the circle. So the each side of the rhombus is given. From that we can easily find its perimeter, which is 4 times the length of side of a rhombus. So for rhombus perimeter P is equal to 4 multiplied by A, where A is the length of each side of the rhombus, which in the problem is given as 33. So this much centimeter, which is equal to 132 centimeter, is the perimeter of the rhombus. It is given that the perimeter of the rhombus is equal to the circumference of a circle. So if I consider capital C, so we know that circumference of a circle is 2 pi r. Capital C is equal to 2 pi r, where r is the radius of the circle. So this implies the circumference of the circle will be equal to the perimeter of the rhombus. So we have 132 is equal to 2 pi r. So this implies r is equal to 132 divided by 2 pi, and pi we will consider the value of pi as 22 by 7. So this much centimeter will be the radius of the circle. Let's simplify. This is 132 multiplied by 7 divided by 2 multiplied by 22. This much centimeter. Okay, I guess 622 divides 132 with 6, and this is 3. So this is equal to 21 centimeter. So 21 centimeter is the radius of the circle, which has a circumference equal to the perimeter of the rhombus, whose side was given to be 33 centimeter. Okay, let's see the next problem. Question number 14. Question number 14. Why is it not scrolling? Okay. A wire in the form of a rectangle 18.7 centimeter long and 14.3 centimeter wide is reshaped and bent into the form of a circle. Find the radius of the circle so formed. So this was the wire in the form of a rectangle where the length was given as 18.7 centimeter and the breadth was given to be 14.3 centimeter. And this wire was rebent to form a circle. Let's say this circle will have a radius small r. So definitely the concept is that the perimeter of the length of the wire is fixed, it is not changing. So the entire length of the wire is used up to form the rectangle, which means the perimeter of the rectangle is equal to the length of the wire. So when the wire which was in the shape of a rectangle was rebent into a shape of a circle, then the perimeter or the circumference of the circle will be equal to the length of the wire, which is equal to the perimeter of the rectangle. So the circumference of the circle will be equal to the perimeter of the rectangle. Okay. So for the rectangle, the perimeter is equal to, we know, 2 into length plus breadth. So this will be 2 into 18.7 plus 14.3, this much centimeter, which is equal to 2 multiplied by this is 33 centimeter, which is equal to 66 centimeter is the perimeter of the rectangle, which is also equal to the length of the wire and equal to the circumference of the circle. Okay. The question has asked what will be the radius of the circle. So we know for the circle the circumference is 2 pi r, or the radius is equal to circumference divided by 2 pi. Now we know that the circumference of the circle will be equal to the perimeter of the rectangle, which we have found to be 66 centimeter. So we have c by 2 pi r becomes 66 by 2, and the value of pi we will consider as 22 by 7. So this is 66 66 multiplied by 7 divided by 2 into 22, this much centimeter, which is equal to so this is 3, this is 21 by 2 centimeter, which is equal to 10.5 centimeter. So the radius of the circle form is 10.5 centimeter. So the main concept is that the perimeter of the rectangle will be equal to the circumference of the circle, because it is the same wire that was in the form of a rectangle, which was then rebent into to form a circle. So the length of the wire is fixed, and the length of the wire will be equal was initially equal to the perimeter of the rectangle, and the length of the wire will also be equal to the circumference of the circle, which means that the circumference of the circle will be equal to the perimeter of the rectangle. Okay, let's see the next problem. Question number 15. A wire is looped in the form of a circle of radius 35 centimeter. A wire is looped in the form of a circle basically means that a wire is in the shape of a circle of radius 35 centimeter. If it is rebent in the form of a square, what will be the length of each side of the square? So here also the concept is same. In this case, in this problem, a wire is initially in the shape of a circle, and then it is rebent to form a square. So the perimeter of the square so the perimeter of the square will be equal to the perimeter of the circle, or the circumference of the circle. The radius of the circle is given to be 35 centimeter. So let's see what is the circumference of the circle. C is equal to 2 pi r, which is 2 multiplied by 22 by 7 multiplied by r is given as 35. So this much centimeter is the circumference, which after simplification becomes 510 or 220. 220 centimeter is the circumference of the circle, which means that 220 centimeter is the length of the wire. Now when it was rebent into a square, let's say rebent into a square, the problem is asking what will be the length of each side of the square. So let's say the length of each side of the square is x centimeter. So so we must have the okay. So let length length of side of square be x centimeter. So this implies perimeter of square is equal to, we know, 4x centimeter. Okay, so this implies the perimeter of the square will be equal to the circumference of the circle. So we must have 4x is equal to 220. So this implies x is equal to 220 divided by 4, which is equal to 55 55. So x is not 55 centimeter, but x is 55. So this implies that length of side of square is equal to 55 centimeter. Okay, next let's do the next problem. Question number 16. A well of diameter 140 centimeter has a stone parapet around it. I have no idea what is meant by a stone parapet. I think a kind of road or path. If the length of the outer edge of the parapet is 616 centimeter, find the width of the parapet. Okay, so it's a kind of so there is a kind of circular path which is termed in this problem as a parapet. I don't know what is the meaning of a parapet. I'm considering as a path. So there is a path around the well which is in the form of a circle having a diameter of 140 centimeter. So basically, let's say this is the well. Let's say, so this is the diameter, this is the circle. So for the well, diameter is given to be 140 centimeter. Okay, and there is a so this is the outer circle of the parapet. This is the outer circle of the parapet, which is basically concentric with the well. And the question is asking if the length of the outer edge of the parapet is 616 centimeter. Now, length of the outer edge of the parapet means the circumference of the outer edge means the outer circle, and the length of the outer edge means the length of the circumference of the outer circle. Okay, so let's say let's say so the diameter of the well is given to be 140 centimeter. So this implies let's say the small r denotes the radius of the well. So we will have r is equal to d by 2, which is 70 centimeter. Okay, now find the width of the parapet. Okay, now let's say the width of the parapet is let's say is small m. So, and let's say the radius of the outer edge of the parapet is a capital R. So definitely, if the width of the parapet is small m and the radius of the outer edge of the parapet is capital R and the radius of the well is R, we will obviously have the width will be equal to R minus capital R minus small r. Okay, now and what is 616 centimeter? It is the circumference of the outer edge, which means the circumference of the circle of radius capital R. So if I consider C capital R is equal to 2 pi r. C capital R is the circumference of the outer edge. This implies that which is given to be 616 centimeter. So we have 616 is equal to 2 pi r. This implies capital R is equal to 616 divided by 2 pi. This much centimeter, which is equal to 616 divided by pi we will consider as 22 by 7, this much centimeter. which is equal to 616 multiplied by 7 divided by 2 multiplied by 22, this much centimeter. So this okay. Let's try to divide 616 by 22. So this will be 2, 44, 44 and 17, 17, 17. Okay, so 28 and 2, 140. So this is equal to 91 centimeter. Capital R is 91 centimeter. That is the radius of the outer edge of the parapet. So obviously now the width we know, small m is nothing but capital R minus small r. So this is equal to 91 minus 70, this much centimeter, which is equal to 21 centimeter, and my answer is wrong. Let me see. I definitely have done some calculation mistake. If the length of the outer edge of the parapet is 616 centimeter. Okay, so 616 is equal to 2 pi r, and so capital R will be 616 by 2 pi, which is 616 by 2 into 22 by 7. Okay, so 616 multiplied by 7 divided by 2 into 22. 22 will divide 616 with 44 and 17, 176. So it must be 8. Okay, so 8. Okay, and 2, 14. Oh, sorry, this is not 91. This is 98. 7 multiplied by 14 is 98. Okay, 98. So we have the width of the stone parapet is 28 centimeter. Okay, let's do the next problem. Question number 17 says, find the distance covered by the wheel of a bus in 2000 rotations if the diameter of the wheel is 98 centimeter. Okay, so we know that so if this is a wheel, if this is consider this as the wheel, and the wheel is so a bus is traveling, so we have so this is the road. Let's say this is the road, this is the road on which the bus is traveling, and the circle is the wheel. Okay, so this wheel has a radius, let's say small r, and small r is given to be if the diameter of the wheel is 98 centimeter. Okay, so the diameter of the wheel is given 98 centimeter, so the radius will be 98 by 2 centimeter, which is equal to 49 centimeter. So the radius of the wheel of the bus is given to be 49 centimeter. Okay, now what is the distance covered by the wheel of a bus in 2000 rotations? So the wheel is rotating, because the wheel is rotating on the surface of the road, the bus is moving. Now in one rotation, the distance covered, the distance moved on the road by the bus is equal to the circumference of the wheel. This concept you must know or understand. So distance covered by wheel in one rotation is equal to the circumference of the wheel, which I am denoting with CR, C small r, since r small r is the radius of the wheel. So this is the concept that in one rotation the distance moved or the distance covered by the wheel is equal to the circumference of the wheel. Okay, and the problem is asking find the distance covered by the wheel of a bus in 2000 rotations. So definitely in one rotation, if the wheel moves a certain distance, let's say x distance, whatever that x be, then in 2 rotation it will move 2x distance, in 3 rotation it will move 3x rotation. So it basically based on unitary method. So distance covered by wheel in 2000 rotations will be equal to CR multiplied by 2000, where CR is the circumference of the wheel. Okay. Now what is so what is CR? CR is 2 pi small r. This multiplied by 2000. R we know is 49 centimeter. So let's calculate this. 2 into pi is 22 by 7 and R is 49 multiplied by 2000. This whole centimeter. This is the distance traveled by the wheel of the car, the wheel of the bus in 2000 rotations. If you simplify this, we have 7 and then we have 4, 88, 88 multiplied by 7 multiplied by 1000. Okay. What is 88 multiplied by 7? 56 and 56, 61. 616 and 000. This much centimeter should be the distance covered by the wheel in 2000 rotations. What is the answer? 6160 meter. Okay, so it is given in meter. So definitely this is equal to 616000 divided by 100 meter. We know, because we know 1 meter is equal to 100 centimeter, or 1 centimeter is equal to 1 by 100 meter. So 616000 centimeter will be equal to 616000 divided by 100 meter, which is equal to 6160 meter. So the concept was that in one rotation, any wheel of a bus or car, the distance traveled by a wheel in one rotation, sometimes rotation is also termed as a revolution. So in one rotation or in one revolution, a wheel covers a distance equal to the circumference of the wheel, which is basically a circle. Okay. Let's see the next problem. Question number 18. The diameter of a wheel of a cycle is 70 centimeter. How far it will go in 250 revolutions? So it is basically the same problem. This time it is the wheel of a cycle. Okay. So the diameter is given. So D is given to be 70 centimeter. This time I will not find R, because anyway, since we have to find the circumference, and circumference is 2 pi r, which is or pi d. So we can straight away use the value of d. So circumference of the wheel, if C is if C is the circumference of the wheel, then C will be equal to pi d, where d is the diameter of the wheel. Okay. So how far it will go in 250 revolutions? So we know that in one revolution, distance covered by wheel is equal to C, that is the circumference of the wheel. So this implies in 250 revolution, distance covered by wheel will be equal to C multiplied by 250. What is C? C is equal to pi d multiplied by 250. We know that C is equal to 2 pi r. C is equal to 2 pi r, where r is the radius of a circle, which is also equal to pi d, because twice r is the diameter. So this is also equal to pi d. Okay. So what is pi? We are taking 22 by 7 and d is 70, and we have multiplied by 250. So this much centimeter is the distance covered by the wheel in 250 revolutions. So this is equal to 10, and how much is 25 multiplied by 22? It is 50 So 550, 550, 550, 0. This much centimeter is the distance covered. We have to find the result in meter. So this will be equal to 55000 divided by 100 meter, which is equal to 550 meter. Okay, let's see the next problem. The diameter of the wheel of a car is 77 centimeter. How many revolutions it will make to travel 121 kilometer? So this is a little different, a different variation of the previous three problems. So this time it is asking how many revolutions the wheel has to make so that it covers the distance of 121 kilometer. Okay. So what is given? The diameter is given. D is given to be 77 centimeter. Okay. What will be the circumference of the wheel? C will be equal to pi d. Okay. Now we know. Let in n revolutions, the wheel travels or covers a distance of, it means the same thing, travels 121 kilometer. Okay. Now let's convert the 121 kilometer into centimeter, because the diameter of the wheel is given in centimeter. So this is 121 kilometer, or 121 kilometer, or 121 multiplied by 1000 will give meter, and then again multiplied by 100, this much centimeter. Okay, 121 kilometer means 121 multiplied by 1000 multiplied by 100 centimeter. Okay. So we are assuming that in n revolutions the wheel travels 121 kilometer. Okay. Now this okay. So what will be the distance traveled by the wheel in n revolutions? We know the distance traveled by wheel in n revolutions will be equal to circumference multiplied by n, this much centimeter, where circumference is in centimeter. Okay. In n revolutions, the distance traveled by the wheel should be equal to c multiplied by n, where c is the circumference of the wheel. Okay. So this implies that we must have a c multiplied by n should be equal to 121 multiplied by 1000 multiplied by 100. Okay. So this implies capital N should be equal to 121 multiplied by 1000 multiplied by 100 divided by c. Now what is c? C is equal to pi d. C is equal to pi d, which is equal to 22 by pi. We are taking the value pi as 22 by 7. So pi d will be 22 by 7 multiplied by d was 77, which is equal to 11. 22 multiplied by 11. So 22 multiplied by 11, this much centimeter is the circumference. So this so now n becomes 121 multiplied by 1000 multiplied by 100, and c we have found to be 22 multiplied by 11. So 11 cancels 121 with 11, 11 cancels 22 with 2, 2 cancels 100 with 50. So this is equal to 50000. So 50,000 revolutions has to be made by the wheel of the car so that it travels a distance of 121 kilometer. Okay, let's do the next problem. Question number 20. A bicycle wheel makes 5000 revolutions in moving 11 kilometer. Find the circumference and diameter of the wheel. Okay, so this time the diameter of the wheel is not given, but it is given that the wheel travels a distance of 11 kilometer in 5000 revolutions. Okay, so we have to find the circumference and the diameter of the wheel. Okay, let's consider the diameter. Let d be diameter of wheel, that is d centimeter. This implies the circumference of the wheel will be equal to pi d. Okay, and the distance. Okay, so this implies a distance traveled by wheel in 5000 revolutions will be equal to c multiplied by 5000, this much distance, where c is the circumference of the wheel. Okay, and the distance is given to be 11 kilometer. Okay, now what is pi d? Pi d is we don't know d. We have to find d. Okay, we have to find d. Okay, so this is equal to pi d multiplied by 5000. Now this implies that we must have pi d multiplied by 5000 should be equal to 11 kilometer. Now we okay, so 11 kilometer. Okay, now we have assumed the d to be in centimeter, that is, let a d centimeter be diameter of the wheel. So pi d multiplied by 5000, this will be in centimeter. Okay, so based on the assumption that d is the diameter of the wheel, we know that the circumference of the wheel will be pi d, and in 5000 revolutions it will cover a distance of pi d multiplied by 5000 centimeter, which is given to be 11 kilometer. So we must have pi d multiplied by 5000 should be equal to 11 kilometer. Now 11 kilometer means 11 multiplied by 1000, this much meter, and then multiplied by 100, this much centimeter. Okay, so now we will have d is equal to 11 multiplied by 1000 multiplied by 100 divided by pi multiplied by 5000. Pi, we will take the value of pi as 22 by 7, so it becomes 100 multiplied by 7 divided by 22 multiplied by 5000. Okay, so 100 divides 5000 with 50. Okay, 50 divides 1000 with 20. Okay, and 11 divides 22 with 2, and 2 divides 20 with 10. So this becomes equal to 70 centimeter. So d, that is the diameter of the wheel, is 70 centimeter. So this implies the problem has asked to find the diameter and circumference. So c will be equal to pi d, which is equal to 22 by 7 multiplied by 70, this much centimeter, which is equal to 220 centimeter. So the circumference is 220 centimeter and the diameter is 70 centimeter. Okay, let's do the last problem, that is question number 21. the hour and minute hands of a clock are 4.2 centimeter and 7 centimeter long respectively. Find the sum of the distances covered by their tips in one day. Okay. Find the sum of the distances covered by their tips in one day. So a clock, so we have a clock, and let's say from the center, let's say this is the this is the let's say hour hand. This is our hand. So the hour hand moves as time passes by. It moves, and when it moves, definitely the distance it travels is like the circumference of a circle whose radius is the length of the hour. Let's say the length of the hour I am denoting is since the hour hand is bigger than the minute hand, I am denoting the length of the hour hand as capital R. So when it is moving, it is forming a circle. It is forming a circle like this. So definitely the problem is asking find the sum of the distance covered by the tips in one day. Now we know that in our hand, okay, so in 1 hour, no, not in 1 hour, okay, in one day, okay. So we know that in 12 hours, the hour hand will complete one revolution or one rotation. That is, when the hour hand is moving, along the circumference of the circle. So in 12 hours, definitely it will complete the distance traveled by the hour hand will be equal to the circumference of the circle formed by the hour hand. And how many 12 hours are there in one day? There are 2 12 hours. So definitely the hour hand in one day, that is in 24 hours, the hour hand will complete 2 revolutions or 2 rotations. That is, the hour hand will cover a distance of 2 times the circumference of the circle. Okay. And similarly, let's say we have this clock, the same clock, and from here we are having the minute. Let's say this is the minute hand. Let's say the length of the minute hand is R. So this is also, when it is moving, it is moving in a path of a circle. It is forming a circle. Okay. And how much time it takes to complete one rotation, a full rotation? Since it's a minute hand, it will take 1 hour, because we know that 60 minutes is equal to 1 hour, and after 60 minutes it will complete one rotation. Okay. Okay, so let's first find out what is the circumference of the circle formed by the hour hand. So when the hour hand is moving, it is moving in a circle whose radius is equal to capital R, which is given to be the length of the hour hand. So C capital R is equal to 2 pi capital R. 2 pi capital R. Okay. And so how many, so in one day, so the problem has asked for sum of the distance covered by the tips in one day. So in one day we need to find how many rotations the hour hand is making and how many rotations the minute hand is making. So as explained before, that how many rotations the hour hand will make in one day. In 12 hours, so we know that in 12 hours, hour hand makes one rotation. So this implies in one day or 24 hours hour hand. Using basic concept of unitary method, in one day or 24 hours, hour hand makes 24 by 12 or 2 rotations. 2 rotations is made by the hour hand in one day. Okay, so this implies distance traveled by tip of hour hand in 2 rotations will be equal to C capital R multiplied by 2. Okay, which is equal to 2 pi r, 2 capital R multiplied by 2. Now let's find out what is the value of 2 pi capital R multiplied by 2, where we know that capital R, the length of the hour hand is given to be 7. I'm sorry, the length of the hour hand is obviously smaller than the minute hand. So I should have usually capital R is used to denote the length of the radius, a larger radius, and small r is used to denote smaller radius. But I have incorrectly used them. Capital R should be used for a minute hand and small r should be used for hour hand. Anyway, so capital R is the length of, so I should say that in 12 hours hand, 12 hours it should be okay. So basically this should be small r and this should be capital R, even though small r is looking larger than capital R. But anyway, please note that I am using the small r to be the length of the hour hand. Small r to be the length of the hour hand because the hour hand is smaller. This is CR, and capital R to be the length of the minute's hand. So capital R is given to be 7 centimeter, that is the length of the minute hand is 7 centimeter, and small r is the length of the hour hand, which is given to be 4.2 centimeter. Okay, so now in 12 hours hour hand makes one rotation, and in one day or 24 hours hour hand makes 24 by 12 or 2 rotations. Now distance traveled by tip of hour hand in 2 rotations is not C capital R but C small r. C smaller, and obviously okay, now C capital R will be equal to 2 pi capital R. Okay, so this is small r, this is small r. Okay, now what let's find out the value of 2 pi. So 2 pi is 22 by 7 multiplied by small r is 4.2 multiplied by 2. So this much centimeter is traveled by the tip of the hour hand, which is making a total of 2 rotations in one day. This is equal to 7 divides 4.2 with 0.6, and we have 88 multiplied by 0.6 centimeter, which is equal to 552.8 centimeter is the distance traveled by the hour hand. So similarly, we have to find the distance traveled by the tip of the minute hand. Okay, so we know that in 60 minutes or 1 hour, the minute hand makes one rotation. Okay, so this implies in one day or 24 hours, the minute hand makes 24 rotations. In 1 hour, the minute hand makes 60 minutes. In 1 hour, the minute hand makes 24 rotation, one rotation. So in 24 hours, it will make 24 rotations. So this implies distance traveled by minute hand in one day, in the distance traveled by minute hand in 24 rotations will be equal to C capital R multiplied by 24. C capital R is the circumference of the circle that is formed when the minute hand is rotating. Okay, so this is equal to 2 pi capital R multiplied by 24, this much centimeter. Okay, this is equal to 2 multiplied by 22 by 7. Capital R was 7 centimeter. 7 multiplied by 24, this much centimeter. This is equal to 44 multiplied by 24, 16996. So 1056 centimeter is the distance traveled by the minute hand in one day. Okay, so this implies total distance traveled by minute and hour hand in one day is equal to 52.8 plus 1056, this much centimeter, and this is equal to 8.8 and then 10 1108.8 centimeter. 1108.8 centimeter. Okay, so this was, I think, a good conceptual problem based on time and how the hour, that is the time concept of hour hand and minute hand in a clock, and the fact that when a hour hand moves, it basically moves in a circle which has the radius equal to the length of the hour hand or minute hand. So with this, it comes to an end in solving the rest of the problems of exercise 20E, which were all these problems of exercise 20E were based on circumference of a circle. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So I have completed all the exercise problems from the chapter of mensuration. The next problem, the next exercise is 20F, which is objective questions, which are objective MCQ questions. There are a total of how many questions? There are a total of let me check. So 20F, the exercise 20F has, exercise 20F is based on the area of a circle, and the area which most of the problems are area of a shaded region, which are based on circles. So exercise 20F has 16 problems. I will try to solve all of them in one video. And then exercise 20G is objective questions. There are a total of 32 questions which I will solve in 3 videos. And then after exercise 20G, we have the test paper 20, which is based on the entire chapter of mensuration. I will solve that. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.